Okay, so we're going to run through a bit of idiomatic Gradle plugin writing. And I'm pretty much going to shoot through a couple of things very, very fast. Yeah, but first about me. That's my email address, my Twitter handle if you want to get hold of me. Unfortunately, I think I have a perverse affinity for both systems. So I tend to work with a lot of them. And I've actually written quite a number of plugins for Gradle. I've been involved with the ASCII Doctor Gradle plugin. I got involved with JRuby last year, even though I can hardly write a line of Ruby. Actually helped the guys offer quite a number of plugins to actually get JRuby into Gradle. And we even actually working on a prototype now to try and actually reflect rake back into Gradle as well, in the same way that you can get ANT. And there's a couple of other things that I've done. So, about this presentation, as I say, we've actually written this in ASCII Doctor. We used Reveal.js plugin for ASCII Doctor to write it. And it's actually built by Gradle. So, I've tried to actually even fix the colors on this, but unfortunately you can see one or two colors are not as good. Didn't expect this with the projector. But that's actually how it's built, so it's very, very easy to, Gradle provides you with a lot of different kind of ways of doing things, and it is actually quite a diverse build system, which is really great. But when we come to plugins, I think the big problem today is that plugin authors, there's no consistent way for them to actually author plugins. So one of the things I actually want to try and address with this talk is to say, well, here's a couple of ways I think you can actually write your plugins. And the focus is not actually on how you write code in the backend necessarily, but it's how you present this extension to the Gradle DSL to the users. And I think that's very, very important. For my kind of thing, there is definitely a very, very big focus on doing that. And that's why I said there's a couple of things in a DSL. It needs to be really readable. I like consistency. So if you just mix and match metaphors in your extension, it doesn't look good. I like flexibility, and this is one of the great things about Gradle, is you can write a very nice build script, and if it doesn't, and that works for most cases, but when it does not work for you, you can always fall back and use the underlying Ruby to do stuff for you. So that gives you that flexibility. Obviously the flexibility comes with a price. You can write absolutely horrendous build systems, so you have to be disciplined about it. And this actually comes up with this other conversation. I don't know if you heard about the so-called halting problem with Gradle. Yes, actually that's not unique to Gradle. As any actually build system, whether it was scons or cons or rake for that matter, they all suffer from the same problem because they actually use a standard programming language underneath. And as long as you don't get hang yourself, it's fine, because this is, as I always say, I'm an engineer. I like to get stuff that works. I am not a computer scientist. So for me, Gradle mostly works, and I'm not going to write stuff that actually explicitly is going to hang stuff up. So I want to put that one to bed. Anyway, so the other thing is actually also you like to have expressiveness in Gradle or in any kind of DSL, so people should not just be able to have a script to do stuff, but when they actually read it, they must get an immediate sense of what it's doing. And that's the kind of things you want to put in. So the other thing that also comes with it when trying to write plugins is, this is my guidelines for getting the best compatibility. It's currently Gradle 2.x, minimum JDK support is 1.6. So if you write on Gradle 2, your plugin needs to support 1.6. Unless there is a very good reason that you need 1.7 or 1.8 or further. Otherwise, make sure it can actually build, because it will come back to bite you, and you will just have to release it because you just built it on JDK 7 and somebody comes back and raises an issue on GitHub and says, it doesn't work and I need it on JDK 6. So if you're still, unfortunately, still building some stuff before Gradle 2, then you have to support 1.5. What I would just say is, anything that you actually build now, you pretty much use Gradle 2. But if you build a plugin, the suggestion is you actually build with Gradle 2.0 for best compatibility. because you might just actually build stuff for a later version of Gradle, it might still not be backwards compatible. So if you want to get a big range, stick with Gradle 2.0. Unless, once again, you need to build a plugin which relies on a feature that's in a newer release of Gradle. So it doesn't actually, you actually need these two strings in your build of Gradle, and you can't actually see that. That says 1.6. That's really, really bad. Check that. And the other kind of thing is obviously if you use the wrapper, make sure it actually points to Gradle 2.0. Okay, so if there's anything else that doesn't show properly, I'll try to explain it. So just kind of thing in this talk, I just want to look at 4 things first. Gradle normally, because it's Groovy, people tend to talk about 2 things. Or in a Gradle documentation, it talks about properties and methods. But if you look at it from a DSL point of view, they are sort of interchangeable. So I use the term attributes, which means there's anything in that configuration that sets something for you. If you want to dig down a bit further into the technicalities, obviously properties is what typically is going to be a Groovy property. And anything else is a method. And then another thing, a user, when I talk about a user in this presentation, it's about a person who actually executes a script or a person actually consuming a plugin, means other words, a script author. So this, if you want to distinguish between a normal property, would just be like you would do in Groovy. You set a string and have an annotation on it. That one says input. And you could have a method. But the way I see it, they are both attributes for me of the extension. Okay. And the only difference we actually see, difference between the properties and methods when it comes in is actually the way you can use them. I prefer to tell people to use methods rather than properties because, for one, it actually gives you a lot more flexibility, and I'll show you examples why I say so. And it also tends to give you proper or better readability because with properties you always need to have an equal signing. So by removing like little operators out of the DSL, things just become more readable. But assignment has certain values in terms of semantics. It's very good if you want to show one-shot assignments. Like we typically only will set one thing somewhere and leave it. It's very good when you do project extensions. It fits very well with Boolean values because typically if you have a Boolean value, the only thing you can say is either equal to true or equal to false. And it doesn't really always work well to make that a method. The other problem is actually if you do assignment, if you don't want to do lazy evaluation, if you just want to power the things you can do with Gradle, then assignment can still work. Just feel free to stop me and ask me anything, especially if you find the black slide part. Okay, but there isn't actually too much in here. Right, okay. So I've got a thing that's called how not to's. First thing, and now I'm going to start with files, because collections of files are the thing that people use the most when writing plugins generally. They want a bunch of files as an input, they're going to do something with them. So the typical implementation people do is simply to say, I want a list of files in a certain property and it's part of my task. The problem with that is, even though you can write it, the only way you can start writing this DSL, when you actually configure the task, you have to say my task equals, and then you put square brackets in there. So immediately that has 2 problems. Well, I think DSL is ugly, but 2 is, if you somehow want to make it more readable, you would like to maybe say, well, that's the problem. Actually, that's my sources. I do apologize. So you're going to say my sources, file 1, my sources, file 2, my sources, file 3. It looks much better than this. Also, the square brackets affect the readability. And then the other problem is it's pretty much a single assignment, so you're not going to get that kind of readability. So you start actually building this big list, and sometimes you want to combine things from different sources. So there's a couple of kind of things you don't really want to do. So you might want to file if you're going to start writing your plugin like this, but if you really want to release it, you want to get it a bit better. So you really want this kind of structure where you can use it multiple ways. And you can actually use a couple of ways. You can use the file function from Gradle, you can use the standard Java new file. And that one is just a string. So you can just put strings within, and now we actually put a closure in, which gives you a lot of flexibility. And suddenly, I can start using lazy evaluation. I can decide, at this point in time when I configure this, I'm not sure which files it has to be. I want to use that list of files at the latest possible time I actually want to evaluate it. So as you can put the closure in there. Now you can start thinking, geez, how can I do all of this? It's actually a lot of work to do, but it's not really. What we actually do is, and I understand this is the point where you actually start the collection of files, is ignore the Groovy shortcut which gives you getters and setters. Write free methods. So I am actually going to create a thing that says get documents, set documents, and I'm going to create another one called documents. And in that way, the next thing we actually have to do is you don't put an annotation on the property, you actually put it on the getter. And this will look nice, kind of things that will happen. So it's pretty simple in reality. In a set, you will always clear. Okay. Let's assume there is a property, or there's actually a in the class called the documents, and you will just clear it and add everything. That's your normal setup. Okay. And when you get, we're going to leave the get. The first thing is out of it, you just have a mobile method called documents. And at that point, you just do add all, and you pretty much add things to the back of it. And then you call this magic function when you do the get. And what we actually do with this is it will handle a whole bunch of objects. So if we make documents, instead of setting documents to be a list of files, we make it a list of objects. And what project of files will do for you, and it's nicely fanciful handled by the Gradle API. It will decide, is it a string, is it a file, is it anything else that's convertible, is it a closure? And it will go work it all out. So by doing this, at the last moment when you do the evaluation, and only at that point we'll actually go and evaluate the closure with all of whatever happens inside it. So this actually allows you to write things very, very simple, and this gives you a nice kind of structure. So just go back to that. So now suddenly you can do that. And if you actually work with something like, I think, for instance, the ASCII doctor configuration does this quite nicely, where you can just add a list of things together, and we'll just add it. So this is the first thing I'm going to say. This, if you do find, this is pretty much what you can do, and I'll fix this slide like that. And the last thing is just put in a thing, this list of objects, nothing else. Object is a wonderful thing inside Gradle. Now, the other thing, as I said, when you get to start, always, when you work with a task, is to actually always provide the default instantiation of your class. Because people want to start using the default instantiation of your task. Because people always want to start working very quickly. But keep in mind that a user might want to create additional tasks at that time. And make it easy for them to do. Now, how many of you have been using the bin tray plugin? Right. It's a useful thing. If you try to create a second instance of that to publish, because there's a very useful case, because you might not only want to publish to your Maven repository, you might want to publish to generic repository as well. You can't, because the plugin is written in a very overly complex way for what is necessary. And what they do is the task is configured afterwards from whatever is put into a into a extension. And it uses the build listener to do this. It's the way you shouldn't actually write it. So that makes it very difficult for somebody to actually achieve flexibility. So always do those two kind of things, but it's useful firstly. The default task instantiator, what most people would use, and allow to create those extra tasks. And also know your annotations. These are some of the most important things for actually writing tasks. And the reason why you want these annotations is this actually what provides you the caching in, I think that's the correct term, in Gradle. It actually caches your task properties for them, so it actually knows when to rerun the task or not as well. So it will actually cache all the inputs and outputs. And you can actually distinguish between inputs and outputs. And optional is important because optional tells it that whether something needs to be set or not, because some properties you might not want to set. So go and read those ones, they're well documented in the Gradle documentation. Okay, we get to the same kind of thing, and this one we actually did have on our list of objects, so there's your example. Strings is like files. The same kind of thing is, let's get a lot of flexibility in there by once again using our three methods. And if we have a little private, we may normally make this one private, hide it away, and then we just act upon it. Once again, we have a setter which will reset stuff. It will do a single assignment if you need it, and then you can append to it. And then the thing with strings is another magic function in here. Well, I like to call them magic functions, but that's such a lot of work for you. Collection utils are string eyes, which you just import, and what it will do is the same kind of things. It will actually go and put closures together. It will actually go and evaluate everything and make them into a list of strings. So, irrespective of how you've actually done this, so it's very, very quick, but you get a bit of DSL out of that. Okay, I'll stop forever. Do you have questions on this? Because these are two easy ones. These are your two biggest wins as well. Okay, so maps. Once again with maps, if you just do the classic implementation, you will have to start putting square brackets in there, and you have to do an assignment. So if you actually, once again, do the same kind of thing, you really want to do this with maps. And I've actually put this line in there, so sometimes this is actually very useful because you might actually, or somebody might actually want to use a task, but it has a default value on a set of properties, or one of them is actually a map, but you don't want it, so you need to reset it. So that's the reason you actually want to have that in there. If you look at the Java exec task, it actually does this with the environment. It gives you a default environment, and you can actually go and override it. You say, I don't want to inherit what's in my environment, and you can just say set environment equals curly bracket, square brackets with a dot, and it actually resets the whole environment, and then you can add your own environment variables. So that's a little thing, but it makes your life a lot easier for users. And the implementation of that is pretty easy. It's the same kind of pattern that we followed, and we've effectively just add things in. And you can decide, yeah, I want to do this, but it's pretty trivial. That's a pretty trivial implementation. If you want to do more complex stuff, you can. But it's kind of this triad of three methods you always have to implement. Now, okay, that was relatively easy. But what if you want to do something that's even more fun? Right, if you work with ASCII Doctor, for instance, or the plugin, and it has happened in the past so that the version of ASCII Doctor J, for instance, a new version gets released, but the plugin is still fixed to the old version. You want to try stuff that's in a new plugin, or in a new ASCII Doctor J. So, because the plugin actually is fixed and is built in as a dependency, you would like to give your user the chance to try another version or a snapshot version without having to rebuild the plugin. Because that actually gives you the flexibility, but you just say, well, we won't support other versions, you can go through this whole kind of spiel. And let's look at that kind of example. So I want to ship my standard version, but I want to be able to give users the flexibility. I then want to decide at a later stage to load a library when it's necessary, but I still want to make use of Gradle's dependency management, because that's really powerful. So I don't want to go roll my own solution, so how can I do this? So, I hate this right now. Okay, so in ASCII Doctor J, for instance, or in the ASCII Doctor plugin, you can select a version of ASCII Doctor J, and you can just say version equals, and you can give it another version string here. The same, for instance, if you use JRuby within Gradle, you can override the current version of JRuby that ships with the plugin. And this actually, and for me, that's pretty simple because I have the flexibility. But how do you actually do this? There's 3 steps to it. Is 1, you have to create a project extension. Number 2 is you have to add that extension object in the apply when you apply the project. And then the third thing is you have to create a custom class load. And I think already, oh, okay. Right. But just think of it, you're going to do a little bit of extra verse writing the plugin, but you're just going to save your user so much time. So let's look at this. The first one is to create a project extension. Now, project extension is relatively easy to write. It's just another class, and you can do anything really with it. What you can put into a class, you put in here. Normally, I like to create it with a project on it, so we can cache the project in it, because you can't actually, if you're inside an object, you don't know, there's no way of looking back as far as I know, so I normally put a project in there to use as well. And so this is going to be my only property on there, for this case, say the version. And it's as simple as that. The next point is to actually add it to the apply. Now, I'm not going to, this is standard, well, that part is standard Gradle plugin writing. I'm going to tell you about it. I assume that if you're writing a plugin, you should at least know about this little part of the top. So the thing you're going to do is just say, create me an extension. So you're going to give your class at the end, which is my extension. But you just give it a name. For instance, ASCII Dr. J, or call it JRuby. Whatever that's going to be, it's just going to appear in your Gradle. So, then the next thing I've also created a configuration. Once again, you can call the configuration whatever you want. This is not the same as an extension. This is important because configurations gets used for dependency management, and the extension is really the thing that you actually see as something that appears in the Gradle scripts which you can configure. For instance, we said ASCII Dr. J, or you will see bin tray. That big block that you have to configure for bin tray, that's actually an extension. That's not a task configuration. And then the other thing that you want to go tell it, and now we get to after evaluate, which Renee referred to. So after evaluate is something that actually Schalk is called at the end of the configuration phase. And what we actually go and do is we go to project dependencies, and well, if you read it like that, without a project on it, that's your normal Gradle that you will see. You just the dependencies. So it's a standard block that you will put into dependencies, but this string here, this ASCII Dr. J is what I've actually created in there. So what I now do is, say at the end, I'm actually going to add a string in there with, and I'm going to put a version in there. So let's see if I can read this for you. Pretty much what I'm going to do is I'm going to put down, say, org of ASCII Doctor, colon, ASCII Doctor, colon, and then I'm going to say, it's my extension or version, whatever gets passed into it. So it will actually work out what it is, and we'll put this closure right in the end. Okay. Is there a question about it? This isn't clear. Okay. So all the slides will be available afterwards, and then at least you can read them in color there. Okay. Okay. Then the first step is to actually create a class loader. And what we do with the class loader, we normally create it when we actually do the task action. That's the one that you normally annotate the task action in your task definition. Now you can do it in different ways, but it's relatively simple to do this. All you have to do is effectively now go and pull all the URLs from the configuration. Now that ASCII Dr. J is the one we created. So we're going to say from that configuration, just give me all of those files and convert them to URLs. You then get your class loader, and you tell it to load one more classes. And you have your instance, and now you can actually work with it. So this is actually the way that ASCII Doctor, for instance, say, works today. And it's the same way we actually can do it. With Gradle, we've actually taken a different approach because that's even more complex. But very, very simple way, I think, to actually give a lot of flexibility to users. Okay, so after evaluate, so I said there's something that gets executed after the configuration phase has taken place. Every closure that you pass through after evaluate effectively gets into a list, and it's first in, first out as far as I know. So you as a plugin author just have to realize you have no control over what order or when your closure will get executed, because the script author might go put extra stuff in there as well, and other plugins got loaded might put extra stuff in there as well. And if you load plugins in different orders, and they all push stuff into after evaluate, the order of those closures will then obviously change as well. So you have to keep that in mind. So don't assume anything. Right, so project extensions is pretty much what you just showed you, and it is effectively, to Grace said, it's global variables. It's a set of global configs, so you have to treat it with care. Don't go put stuff in there which shouldn't be there. And don't make your, as I said, like for the bin tray example, is don't make that extension configuration block something that starts configuring your tasks. Rather let the task pull information from the extension than the other way around. You must have a very good reason for doing it the other way around. Okay. Okay. Another thing that you can do, and this is when you don't get the fault by Gradle, but you might actually work in a generative environment. You might have to generate code and then build it or add it to extend existing source sets. So, for instance, with the JRuby jar plugin, one of the things that we had to do is we had to add in a custom bootloader as part of the jar that we actually built. And there you actually built the jar, plus you had JRuby components, and you had to put a script and stuff in. So we actually wanted to build a bootstrap code of the class file as part of the script, but I want to make it in a nice way that's actually configurable. So in that kind of case, you actually want to generate code, add that code to the standard set of Java and Groovy files that you actually put into the jar. If you want to do this kind of thing, then for instance, you can do lots of kind of things. I'm actually going to use the copy task as a transformer to transform the code. And then I'm going to create some kind of generated task. I also have to add it, that those files that get created, I have to add it to the source set. And then finally I have to add some dependencies. And that all has to happen in your plugin. So, there's quite a number of steps we're going through here. So we can add a generated task. And in reality, what we're just going to create is another task, and yeah, it's a type copy, and we're going to call it something. Just call it my generator. And then at some stage we need to configure it. We have all the steps I just discussed. I just put as 3 method calls, and we'll go through them separately. But that's the basics. So create your generator first, and then go and configure it. And this is the standard kind of thing. You'll give your task that you've created on a file, give it some group and a description, so that somebody, if they run Gradle tasks, that they can actually get a description out. It's not just an empty name that you don't know what it's doing. Then you just have to pull it from some source. Let's say we pull it from a directory called source templates, argument's sake. And we are then actually going to write it somewhere into some of our build directory. And then the last two things we actually do is, because it's a copy, we can't just copy the file, we actually write, because it's maybe a template file, something we might want to rename it, so we actually put the rename in there. And then you put the filter in there. So all of these things are standard copies from the copy task. The filter is just going to manipulate my generator. So that's a simple generator task. Not the most important part in here, but it's just an example what you can actually do a generator. The next one is actually more important. Once I've actually written this code, I need to add it somewhere to the source set. And what you will actually do is you'll just run through project.sourcesets, which is all the source sets, and you will look for things where the name matches a pattern. And for instance, you would just say action something where the name matches a pattern of a configuration. So if you're aware, if you're writing Java code or Groovy code, there's this, normally you lay out the source, main, etc. And then the source debug. Normally those things actually match the name. So I'm going to look for everything through main, and then I'm going to actually find all of my source code and just add them into there. And that's a simple way of actually adding more source into a standard source. Yes. That's a good question. I don't actually know now. Because I think why I wanted to use matching, originally there was more complex an example I used elsewhere. I'll just cut it down to that.
Yeah, it might be also a timing issue.
Yeah.
If you line up the one first,
Yeah.
then you will go. But that would work, but
Yeah.
projects also really would work. You apply ASCII documents.
Yes.
But
Okay. Right.
that's it.
Okay. Good. Okay, so the next thing is to actually add dependencies. So my generated task and my compile task are two separate ones. So what I want to do is to have the compile task linked. So if something changes in the generator, I still want to recompile, otherwise I wouldn't know about it. So the big problem here is currently there's two ways, and this is to do with order of plugins. If you want to add to something that exists, then it's fine. And then you're going to get, this is why this is the block is as big as this. So if I want to do get by name, and that specific task I'm trying to find doesn't exist, the compile Java task, for instance, is going to throw an exception. And then what you can do otherwise, you can say, if I'm going to add something, the task doesn't exist yet, I can say when task added. Now, I don't think there's a way of currently writing it shorter in Gradle. It would be nice if you can do those two kind of things in one. Because I don't think when task added actually works if the task already exists.
You could say project task with Java component, matching.
But does that work if the plugin is applied later on as well? Okay. I will find that one.
And the other
Quite
one
short.
that you can just use find plugins, which will be null basically.
Yeah.
So you can.
Okay, yeah. Well, you have some alternatives, yeah? So you can go read about it. The principle still applies. You have to make this linkage. It will be good to get us some examples from later on. Right. So we go back there. So the last part we've actually done, we added the task dependencies. So now if generated code changes, the compile task will actually also run. Okay. We sort of already discussed it. So that's, again, with plugins is you have no control of which order a script courses have to apply plugins. So you have to handle these cases. And if we get a better example, we can put it into a set of slides for that. Okay. Now, you might get to another kind of issue, and is you want to extend an existing task. So a common model is, I don't inherit from a task. But what if you actually want to extend a task from another plugin that exists? So for instance, you actually want to change the jar task, not an instantiation of it, but a physical one, for instance, that gets created by the Java plugin. So you want to add something to that, for instance, because that could be really useful for something you want to do. So this is about adding behavior to an existing task. And I'm going to go back to the example I'm going to use is what I discussed earlier. JRuby, we actually wanted to add the bootstrap class, and actually how do we do this? I'm not saying this is ignored it, because it's a very good way of actually doing inheritance, but sometimes you can't. Sometimes you have to work with what exists. So I'm just going to say, so if we didn't do an extension for this, we might have had a configuration and we had to do a very, very ugly front statement with lots of code. And then we could always use a closure there, and I don't even want to write code because it will be ugly. If we add an extension, we can just say, this is the location of the inner script. And it can then pull that template and do everything with it. And in the background, we do a lot of stuff there. But you can, this is the kind of thing where I talk about expressiveness. I have an idea here, something to do with JRuby and something to do with this inner script. So it tells me something by reading it. If I had to look at that, it's too much to read. Then it becomes like programming, no longer like a build script. So you want to, this is the kind of things you like to provide to users. So if you want to extend the existing task, first thing is really to create an extension class, and then add an extension to the task, and finally you have to link the attributes, and that's quite important. But the one thing you have to know here, see the differences. We talked about the project extension earlier, now we're talking about the task extension. The basics are the same. You create a class and you put whatever properties you wanted there, and then it gets created. And actually in this case, it will actually get created with the task associated with it. So you can do something with that task. And we'll get back to that. So I'm going to show you that code now. So the first thing I want to do is add my extension to the task. And pretty much the same kind of thing is I have a task that I created from earlier, from a previous example. But what I'm now going to say is on that task, I call extensions and I create an extension and I give it a name. And we'll call it JRuby. And that points to my class, which is my extension, and that's the task I've actually passed in as the only value that goes into the constructor. So if you have kind of a constructor with lots of parameters in it, you just add more in here. This is all of the beauty that Gradle gives you. Try to do that at Maven. Okay. Actually try to do that in Schalk or anything like that either. Right, so then other thing we have to do is, and this is important, because we looked at annotations earlier, and we said annotations give you that kind of cache, so that Gradle knows whether it has to execute the task, whether it's up to date or not. If you add an extension to it, you don't have that ability. There is nothing there. So you actually have to tell task, so that Gradle actually will know about extra properties on the task. And so that's what we actually go and do there. So we're going to say, we're going to add this extra property in the task, and we call it whatever name you want to call it. It doesn't really matter. And then you give it a closure. So when it wants to evaluate the properties, whether it's up to date, it calls the closure. And in this case, all I want to say is that closure returns this value. And that's actually get evaluated. That's pretty actually, once again, it's a simple thing to do, but you don't know about this kind of thing. And then you go and change your script in the value of that inner script, and you run Gradle and it doesn't recompile. And you say, what's going on? So, and then you get a bug of GitHub for that. That's what you have to do. Okay. So task extensions is pretty much this. So it's a very nice way of doing composable extensions. And I just showed it. The fact is there's attributes don't get cached, so you have to do extra work on them. And give that user a better experience. Okay, so we're going to talk about some tricks we have. How many minutes do you have? 7. The kind of tricks many times, I think the Gradle authors don't want you to know about. But anyway, I just have to take a tick. Right, okay. So, sometimes you write a plugin, but the plugin you're actually writing depends on functionality in your plugin. It's like self-reference. It's like, I if you had to write, I wrote an unofficial plugin for Bintray before Bintray was out. The problem is you want to publish to Bintray, but you just written a functionality. You want to use this. Okay, so how can you actually reuse your own plugin was writing in the same version? I mean, the classic version is always use the previous version and then change it again. So this is what you pretty much actually do. In your build script, you say apply plugin, new Groovy script engine, and then you give it an array. I should read this properly because I can't even see it. You just pass to your source directory, and the end of it is converted to an array, and give it the current class loader. So you're pretty much going to give it a set of source files, and to go through and give it a class loader. And then the final one, the one down here, is your plugin Groovy source file. Not your task files, but the one that actually has to apply in it. This little trick actually allows you to reload the thing in your own plugin. Okay. You might want to use it for something one day. Yeah. Right, so 5 minutes. Okay. Right. Here's another little trick that you can use. Now we get into an internal API. The ones I complain about, but I say it's really useful and should be public. Sometimes you would like to create, say, file name from some source of data. A very good example is what we've done with ASCII Doctor is there's different backends. You have no control over what the name of the backend is. what we want to output to different directories. I mean, you know if you run ASCII doctor nowadays that it will actually create those directory names by default. But what if that thing had a colon on it, for instance, in your random windows? Okay, simple example. So you want to create save file names. So what you can do is there's a nice little internal API. It's called file utils. You say file utils to save file name. Give it a string and it creates your file name, which is useful. Now he's going to tell me to move it into the free or something. Okay, or he doesn't know about it.
I wrote it, but I
you
don't
did.
remember what I used to.
Yeah. Okay, I can tell you it's very useful. Okay. There is another one, and this is another one I complain about. This is lovely. I mean, you go and you read the documentation, and there's this interface called operating systems, which tells you which operating system you're on. And it can tell you stuff like even what's the path variable and things like that. The problem is the standard Gradle API doesn't give you the instance of it. So you have to go dig around and go inside. And it is actually called, I'll read it from there. It's all Gradle internal OS operating system. That's what you need. And once you have that, you can just say operating system.current. And it actually gives you the current one, and then you can go use all the things that's defined in the documentation. So you can just say, .is Windows, and you know you're on Windows, or whatever. So that's very, very, actually, I think that's really useful. But for many authors it might not be important, but if you actually write stuff where sometimes you have to do something, figure out which operating system you are in, and that becomes very, very useful. Okay, we have 2 minutes. So, we're done. The thing I want to say is pretty much make sure you keep those DSLs really beautiful. And don't bring surprising behavior on your users. So don't do things out of order. Keep the consistency. I like definitely the kind of things to try it. I want to like see a DSL, see as little as possible equal signs in it. And pretty much more spaces I see is generally better. But yeah, it should really read easily, and it should actually express the semantics of what you want to do. So as somebody who doesn't even understand Gradle, to grab the script and have a rough idea what's going on, I say, okay, this guy has something to do, maybe ASCII doctor, yeah, or he's trying to build a jar, yeah. That kind of very easy things to read. That's what you want to achieve. Well, that's it. Any questions? Okay, so I will make the slides available, and these things will be in an upcoming book as well, specifically about actually the writing plugins in the shadow play. That's what it is today. Thank you very much.